Welcome to Dreaming Through Knowledge. Tonight, we journey inward, into the quiet universe behind your eyes, where thoughts are born. We will travel through the folds of the human brain, exploring how billions of tiny cells create every idea, memory, and emotion in perfect silence. If you enjoy these calm explorations through science and wonder, follow the channel and share what you'd like to discover next. I begin by imagining the brain not as a single organ, but as a city made of light. Each neuron a house, each connection a street. From above, the entire landscape glows with tiny flickers, pulses of electricity that represent thought itself. Inside this city, there are no sounds, no sparks, no flames, just waves of voltage shifting across membranes thinner than a strand of hair. The language of the brain is electrical, chemical, and beautifully quiet. The average human brain contains about 86 billion neurons. Each of these cells connects to thousands of others, forming trillions of pathways. If we could trace them all, their total length would stretch farther than the distance from the Earth to the Moon. Every neuron works like a tiny relay station. It receives signals, processes them, and passes them onward. When the electrical charge inside the cell reaches a threshold, it fires, sending a pulse called an action potential along its axon. At the tip, that signal releases chemicals known as neurotransmitters into a microscopic gap between cells, the synapse. Across that gap, the next neuron receives the message, and the chain continues. This process repeats billions of times every second in every brain alive right now. Your thoughts are the choreography of these signals, the coordinated dance of electricity and chemistry weaving patterns that we experience as awareness. The first time I watched neurons fire under a microscope, I was struck by their elegance. Tiny pulses of light traveling down translucent threads, branching like the roots of a tree. They remind me that biology and beauty often share the same design. To understand how thought arises, we start with the brain's architecture. At its base lies the brainstem, ancient, shared with reptiles and early mammals. It controls heartbeat, breathing, and reflexes. Above it rests the limbic system, the emotional core where feelings like fear, pleasure, and memory take shape. And above all, wrapping around these older structures, lies the cerebral cortex, the thin, folded sheet where consciousness blooms. The cortex is only a few millimeters thick, yet spread flat. It would cover a full square meter. Its folds, called gyri and sulci, allow it to fit inside the skull. Each region specializes in different functions. The occipital lobe processes vision. The temporal lobes interpret sound and memory. The parietal lobe integrates touch and space. The frontal lobe plans, decides, and imagines. But thought itself is never confined to one place. When you recall a memory or imagine a sound, activity ripples across many regions at once. The brain thinks in networks, not locations. These networks are constantly changing, strengthening connections that are used often and pruning those that are not. This ability, called neuroplasticity, is what allows learning, healing, and adaptation. Every experience you have reshapes your brain's wiring slightly, leaving behind traces of experience etched in connection strength. It's strange to realize that a memory is not a photograph stored in one spot, but a pattern of connections scattered across the brain. When you remember a place from childhood, one region reconstructs its shape, another its smell, another its emotion. The act of remembering is a form of recreation. your brain rebuilding the moment from fragments each time. In the quiet dark of the skull, these processes unfold continuously. Electrical impulses last only milliseconds, yet their combinations form the flow of awareness we call mind. No single neuron knows what you are thinking, but together, their collective activity becomes the thought itself. It's like a murmuration of starlings. Each bird follows simple rules, align with neighbors, avoid collision, yet the flock as a whole creates patterns of astonishing grace. Consciousness may emerge in much the same way, from simple interactions producing complex order. The energy cost of this dance is high. Though the brain makes up only about 2% of body weight, it consumes roughly 20% of the body's energy. Every thought, perception, and decision depends on the continuous flow of oxygen and glucose delivered by blood. If that supply stops for even a few seconds, consciousness fades. The brain's fuel travels through an elaborate vascular network, over 600 kilometers of capillaries weaving between neurons. Each pulse of the heart sends a tiny wave of nourishment through this landscape. In a sense, your thoughts are powered by the rhythm of your heartbeat. Within this living circuitry, communication is chemical as much as electrical. Different neurotransmitters create different effects. Dopamine signals reward and motivation. Serotonin contributes to mood and calm. Glutamate excites. GABA calms. Each molecule acts like a tone in the orchestra of the mind. Balance is everything. Too much or too little of any neurotransmitter can shift perception, emotion, and behavior. The brain maintains equilibrium through feedback loops, constant monitoring and adjustment moment by moment. When we feel joy or inspiration, it is chemistry at work. Yet that chemistry arises from experience and meaning, not just molecules. Thought and emotion are two sides of the same current. Consider a simple moment. Seeing a friend's face. Light enters your eyes, strikes the retina, and becomes a stream of electrical signals. Those signals travel through the optic nerve to the visual cortex, where patterns of brightness and color assemble into recognition. Almost instantly, deeper structures trigger emotion and memory, warmth, familiarity, affection. What you experience as a single feeling is the synchronized firing of billions of cells. From sensation to perception, milliseconds pass. From perception to thought, another fraction of a second. The mind seems continuous, yet beneath that smooth awareness lies constant electrical storm. Sometimes I imagine listening to it, the hum of billions of signals exchanging quietly in the dark. If you could translate that rhythm into sound, it might resemble waves or wind moving through leaves, the music of thought. Beyond individual neurons, the brain's structure forms larger systems that handle specific kinds of thinking. The hippocampus, curled deep within the temporal lobe, organizes memory and spatial navigation. The amygdala tags experiences with emotion, ensuring that what matters is remembered. The prefrontal cortex coordinates reasoning, planning, and empathy. Together, they give shape to the narrative you call self. The self, however, is not fixed. It changes as neural connections shift. You are not the same brain you were 10 years ago. Every thought, every experience, has rewired parts of your circuitry. Identity is a process, not a possession. The brain also constructs time. Neurons in specific regions measure intervals and sequence events, allowing you to perceive cause and effect. Without these mechanisms, moments would blur into one continuous present. Time, in this sense, is another creation of the mind, a structure built so that thought can organize experience. As we explore deeper, we reach the question that has fascinated philosophers and scientists alike. How does consciousness arise from matter? How can the activity of neurons produce the subjective feeling of awareness, the sense of I am? No complete answer exists yet. Some researchers suggest that consciousness is an emergent property, appearing automatically when a system becomes complex enough. Others propose that certain patterns of neural connectivity give rise to awareness, while some even speculate that consciousness is a fundamental property of the universe, not confined to brains alone. What we do know is that consciousness depends on integration, the coordination of vast amounts of information across the brain. When regions work together seamlessly, awareness arises. When they disconnect, as in deep sleep or anesthesia, consciousness fades. In dreams, the same neurons that perceive the outer world turn inward. The brain creates its own reality, drawing from memory and imagination. To dream is to think without the constraints of sensory input. The images may seem spontaneous, but they are shaped by the same chemistry and circuits that govern waking thought. Even when resting, the brain is never still. A network called the default mode hums quietly when we daydream, recall the past, or imagine the future. It weaves the threads of our internal life, constructing stories about who we are. Every new idea begins as a pattern, neurons firing in novel combinations, linking old memories with new stimuli. Creativity, at its core, is the brain's capacity to connect distant concepts into fresh relationships. The aha moment of insight is the synchronized firing of previously unconnected regions suddenly lighting up together. In those moments, the brain feels unified, as if thought, emotion, and sense all align. Artists, mathematicians, and musicians describe it as flow, a state of effortless concentration when self fades and awareness expands. It is both chemical and transcendent. As we rest, the brain cleans itself. During sleep, specialized glial cells open channels that flush out waste products of metabolism. This process, known as the glymphatic system, is like a nighttime tide washing the shores of consciousness. Without it, toxins accumulate and clarity fades. Dreaming and memory consolidation happen at the same time. The day's experiences are replayed, reorganized, and stored. Connections strengthen, others weaken. When you awaken, you are literally a slightly different brain than when you fell asleep. This constant renewal mirrors the forest or the ocean, systems that remain stable by changing continuously. The mind is not a static object, but a living process. Emotions, too, are patterns of neural activity. They arise from deep structures like the amygdala and hypothalamus, spreading to the cortex where they are named and understood. Feelings guide thought as much as logic does, shaping choices and perceptions. To think clearly is not to silence emotion, but to integrate it. Reason without feeling is blind. Feeling without reason is directionless. The brain's harmony depends on their balance. Language adds another layer to thought. Words allow abstract ideas to take form, linking sound with meaning. When you speak or think verbally, networks in the left hemisphere, particularly Broca's and Wernicke's areas, coordinate the structure of grammar and comprehension. Language lets us share inner patterns with others, extending consciousness beyond a single skull. Still, not all thought is verbal. Much of the mind's activity is visual, emotional, or intuitive, silent flows beneath the surface. The words we speak are only the visible crest of a much deeper current. Even silence, when we pause between thoughts, is active. Neurons reset, rhythms synchronize, and the brain reorganizes itself. Moments of stillness are moments of recalibration. This interplay of activity and rest, of firing and silence, is what gives thought its texture. Without pause, there would be noise. Without quiet, no clarity. The mind, like music, needs both sound and silence to exist. And so, as we continue this quiet tour of the mind, I find awe in its paradox. Billions of cells, each following simple rules, create awareness capable of questioning its own existence. From matter arises meaning. From chemistry, consciousness. The story of the brain is still being written. With every new discovery, every neuron mapped, every circuit understood, we move closer to understanding ourselves. Yet perhaps the greatest wonder is that the very organ seeking this knowledge is the one creating the question. In the next part of this journey, we will explore how the brain's patterns create memory, imagination, and identity, how thought becomes story, and story becomes the self. Memory is the bridge between who we were and who we are. Without it, each moment would vanish as soon as it arrived. The world would remain familiar but empty of meaning, as if seen for the first time again and again. To remember is to travel through time. Every recollection is the brain reaching backward, rebuilding patterns of activity that once represented experience. We do not store the past like film in an archive. We recreate it each time we recall it. When I close my eyes and think of my childhood home, I see light through a window, hear the creak of a floorboard, smell something cooking. None of these sensations exist now, yet the brain summons them through coordinated firing across many regions. Vision in the occipital cortex, sound in the temporal lobe, scent in the olfactory bulb, emotion in the limbic system. All join briefly in harmony to form a single scene. The hippocampus, deep within the temporal lobe, serves as the brain's map maker. It links experiences with time and place, converting fleeting perceptions into lasting traces. When we first encounter something new, neurons within the hippocampus record associations, where we were, who was with us, what we felt. Later, those connections are replayed and transferred to the cortex for long-term storage. Each new memory begins as a pattern of electrical activity. If that pattern repeats, the connections between neurons strengthen. This process, called long-term potentiation, is the molecular basis of learning. Cells that fire together wire together. Over time, the hippocampus becomes less involved. Memories consolidate into networks distributed across the cortex. This frees the hippocampus to record new experiences, while older ones settle into the background of identity. Sleep plays a crucial role in this transfer. During deep sleep, the hippocampus replays recent experiences at high speed, sending echoes through the cortex. It is as though the brain rehearses the day's events, engraving them into long-term storage. Not every detail survives this process. The brain keeps what seems meaningful and lets go of what it deems noise. Forgetting, far from failure, is an essential act of clarity. Without it, we would drown in information. Memory is selective, flexible, and creative. Each time we recall an event, we alter it slightly, influenced by present emotion and context. Memories evolve with us, blending truth and imagination into personal myth. This is why eyewitness accounts differ even among honest observers. The brain reconstructs rather than retrieves. To remember is to imagine the past. There are many kinds of memory. Sensory memory holds impressions for fractions of a second, the brief echo of a sound, the afterimage of light. Short-term memory holds small amounts of information for moments, a phone number repeated silently. When rehearsed or emotionally charged, it may become long-term memory, stored for days or decades. Emotional intensity strengthens retention. The amygdala, next to the hippocampus, flags events that carry significance: danger, joy, love, fear. Its chemical signals enhance consolidation, explaining why we recall moments of strong feeling so vividly. Emotion paints memory in color. Yet emotion can also distort. Traumatic memories may imprint too deeply, replaying unbidden. The same mechanisms that make learning efficient can trap pain. Healing often means teaching the brain new associations, pairing old memories with safety until their charge fades. At the cellular level, memory is encoded in synapses, the junctions where neurons meet. Each experience slightly changes the strength and number of these connections. If we could look inside a neuron before and after learning, we would see its shape altered. Spines on dendrites growing or retracting like coral responding to current. In this way, the brain records experience not in words or pictures, but in structure. The mind changes its own wiring to hold the pattern of the world. Working memory acts as a stage for consciousness. It holds the thoughts we are aware of right now, the words of a sentence, the steps of a plan, the images of imagination. Neurons in the prefrontal cortex keep these representations active by firing in loops, maintaining focus as long as attention endures. When attention drifts, the loop breaks and the thought dissolves. The mind clears space for the next moment. This constant turnover allows flexibility but limits capacity. We can hold only a few pieces of information at once. Technology often compares memory to storage, but the metaphor falls short. Computers copy data exactly. Brains reshape it. Every act of recall reopens the circuit, making it plastic again. This property allows therapy, learning, and creativity, and also makes memory malleable. Imagination uses the same circuitry as memory, but runs it in reverse. Instead of reconstructing what happened, it simulates what could happen. The hippocampus and cortex combine past fragments into new possibilities. To imagine is to remix memory into potential. When you picture a place you have never been, your brain borrows pieces from those you have seen. When you plan tomorrow, you reuse yesterday's pathways. Creativity is memory set free from chronology. Dreams represent the most vivid form of this recombination. During rapid eye movement sleep, the brain activates sensory areas as if awake, but disconnects from external input. It uses stored fragments, sights, sounds, emotions, to create internal worlds. Dreams are memory without reality testing, imagination unrestrained by reason. The line between remembering and imagining is thinner than we think. Brain scans show that the same regions light up when we recall the past or envision the future. Both depend on the hippocampus and its dialogue with the cortex. Memory and foresight are two directions on the same road. Autobiographical memory, the story of who we are, depends on this capacity. It weaves events into narrative, selecting what to keep and what to forget until a coherent self emerges. Without it, identity fragments. With it, life feels continuous. Yet this story is flexible. We edit it constantly, interpreting the past through the lens of the present. Sometimes we soften edges, sometimes we exaggerate. The self is both author and character. Collective memory works in similar ways. Cultures preserve stories that define belonging, shaping identity across generations. Our brains evolved for storytelling because narrative organizes experience. Facts alone are scattered. A story gives them pattern. The rhythm of memory even shapes language. When we speak, we draw from stored words and associations in the temporal lobe, linking them to current context through working memory. Conversation is the real-time retrieval of experience, arranged into sound. Sometimes memories hide below awareness. Procedural memory, stored in the cerebellum and basal ganglia, controls skills like walking, typing, or playing music. These habits run automatically, freeing the conscious mind. Skill learning reshapes different circuits than factual recall, which is why we can forget the name of a song yet still play it flawlessly. Emotional memories reside elsewhere still. A smell can evoke a feeling instantly because olfactory pathways connect directly to the limbic system, bypassing logic. Scent, the oldest sense, touches the deepest layers of memory. Our brains also record patterns of social connection. Neurons mirror the actions of others, helping us learn by observation. These mirror neurons fire both when we act and when we watch someone else act, forming the basis of empathy. We remember not only our own experiences, but the experiences of others through reflection. Forgetting remains as vital as remembering. It clears neural space, allowing adaptation. Connections that go unused weaken through a process called long-term depression. This pruning prevents overload and encourages efficiency. The brain, like a gardener, trims what no longer serves growth. Sometimes forgetting feels painful. The loss of a name, a face, a moment once cherished. Yet even that fading is part of the cycle. Memories transform into impressions, then into feeling, then into wisdom that no longer needs detail. Memory defines continuity. Imagination defines possibility. Between them lies consciousness, the awareness of moving through time. Together, they create the narrative flow of life. As technology begins to map memory circuits more precisely, questions arise. Could we one day enhance recall or even record experience directly? Neuroscience edges toward such possibilities, yet it also reminds us that memory is not mere data. It is emotion, mining, and identity woven together. Even artificial intelligence, built from digital networks, learns by adjusting connection strength, a simplified echo of biological memory. But without sensation or emotion, such systems store without remembering in the human sense. For us, memory is lived experience given shape. When we reflect on the past, we engage both logic and feeling. The prefrontal cortex analyzes. The limbic system colors perception with warmth or sorrow. Together, they turn recollection into reflection. Meditation offers a way to watch these processes quietly. By observing thoughts without attachment, we glimpse how memories rise and fall on their own. The mind reveals itself as movement, images forming and dissolving like waves. the science of memory leads inevitably to philosophy. If our sense of self depends on memory, who are we in the moments we forget? Perhaps identity is not a fixed record, but the capacity to experience anew. Imagination extends that capacity outward. It allows empathy, innovation, and art. By simulating worlds within, the brain rehearses possibilities before acting. Evolution favored this ability because it lets us learn without risk. Through imagination, we also heal. Visualizing safety or success activates the same neural circuits as experiencing them. The brain does not fully distinguish between reality and vivid thought. This is why hope and belief can alter mood, even physiology. When memory looks backward and imagination forward, both illuminate the same truth. The mind is a creative organ. It constructs reality continuously using the raw material of experience. In its silence, the brain holds entire worlds, past, present, and potential, each built from patterns of light inside living cells. In the next part of this story, we will explore emotion and consciousness more deeply. How feelings guide reason, how awareness arises from integration, and how the quiet chemistry of the brain gives shape to the self. Emotion is the color of consciousness. Without it, thought would be flat. Accurate, perhaps, but lifeless. Feeling gives meaning to perception. It is the thread that ties experience to significance. For a long time, science treated emotion and reason as separate, even opposing forces. But the brain shows no such division. Thought and feeling arise together, each shaping the other in a constant loop. Every feeling begins as chemistry. In the deep brain, within regions called the hypothalamus and amygdala, small shifts in molecules signal the body to prepare, to move, to focus, to rest. These signals travel through the bloodstream and nervous system, altering heartbeat, breathing, and attention. When you feel fear, the amygdala detects potential danger and triggers the release of adrenaline. The heart accelerates, pupils widen, muscles tense. If the threat passes, the prefrontal cortex steps in, calming the reaction. Emotion is not chaos, it is coordination. Each basic emotion has its own circuitry. Joy lights up networks involving the nucleus accumbens and dopamine release. Sadness engages regions related to memory and reflection. Anger activates systems for energy and defense. But none of these states exist in isolation. They blend endlessly in the chemistry of daily life. Even subtle feelings, curiosity, nostalgia, serenity, are patterns of brain activity. Electrical rhythms change, neurotransmitters shift, and perception adjusts accordingly. Emotion is the interface between body and mind, translating physical state into subjective experience. The brain constantly monitors the body's condition, a process called interoception. Signals from the heart, lungs, and gut travel to the insular cortex, which integrates them into awareness. When these signals align smoothly, we feel calm. When they conflict, we feel anxiety or discomfort. Emotion, in this sense, is the brain's interpretation of the body's internal landscape. This dialogue between body and brain is ancient. Long before humans spoke or reasoned, organisms needed to evaluate their state, to know hunger, safety, or danger. Feeling is evolution's first form of thinking. Conscious thought emerged later, layered upon these older systems. But the foundation remains emotional. Logic may plan, but emotion decides. Studies show that when parts of the brain responsible for feeling are damaged, decision-making collapses, even when intelligence remains intact. We cannot reason well without caring. In daily life, the relationship between thought and emotion unfolds seamlessly. A sound, a word, or a memory triggers chemical cascades that influence perception. The mind filters reality through mood, highlighting some details and softening others. In a good mood, the world seems open and bright. In sadness, it narrows and slows. Mood itself is like weather, a pattern of emotion that lasts beyond any single moment. It is shaped by hormones, circadian rhythm, and experience. The brain's neurotransmitter systems, dopamine, serotonin, norepinephrine, act like atmospheric conditions, shifting the emotional climate. Within the storm of these reactions lies awareness, the calm center we call consciousness. What is it, this silent observer within? How does a network of cells produce the experience of self, of being here, now, aware? Many theories attempt to describe it. One proposes that consciousness arises from integration, when information from many regions of the brain combines into a unified pattern. Another suggests it emerges from global workspace dynamics, where certain neural signals gain dominance, entering awareness, while others fade into background. In simpler terms, consciousness is what happens when the brain listens to itself. Each sensory system sends streams of data, and higher networks interpret and synthesize them into a coherent model of reality. That model becomes the world we experience. The brain is both artist and audience, painter and observer of its own masterpiece. In deep meditation, this process becomes visible to introspection. When thoughts slow, awareness remains, pure observation without story. Neuroscientists find that such states quiet the default mode network, the system involved in the self-referential thinking. As the chatter fades, consciousness reveals itself as spacious and continuous. At the level of neurons, consciousness is rhythmic. Brain waves, oscillations of electrical activity, synchronized groups of neurons across regions. Different frequencies correspond to different states. Beta waves for active thought, alpha for relaxed focus, theta for dreamlike reflection, delta for deep sleep. These rhythms create temporal coherence, the timing that allows the brain's separate regions to communicate effectively. Without rhythm, awareness would fragment. Some researchers describe consciousness as a process of constant prediction. The brain doesn't just receive information, it anticipates it. Each moment it compares expectation to reality, updating its model of the world. When the prediction matches, perception feels smooth. When it fails, we notice surprise. Pitch 1%. In this view, perception itself is controlled hallucination, a best guess continuously corrected by sensory input. The vivid world around us is our brain's simulation, tuned so finely that we call it real. Emotion guides this predictive process. It tells the brain which information matters. Fear sharpens attention, joy broadens it, sadness narrows it for reflection. Each feeling adjusts the filters through which we interpret reality. Consciousness, then, is not a thing but a process, an ongoing act of integration, prediction, and feeling. It is the conversation between the physical and the imagined. Self-awareness adds another layer. Some regions, particularly the medial prefrontal cortex and the posterior cingulate cortex, track internal states over time. They allow us to think about ourselves, to form identity, to ask, who am I? This self, however, is not fixed. It shifts with context, emotion, and memory. Under stress, identity contracts around survival. In safety, it expands into empathy and curiosity. When networks associated with the self quiet down, during meditation, flow, or awe, the boundary between observer and world softens. We feel connected, absorbed in the present. Such experiences hint that consciousness may not be a property of individuals alone, but of interaction. Perhaps awareness is like light. It seems to belong to the object it illuminates, yet it is independent, a condition that makes seeing possible. Emotion illuminates consciousness in a similar way. It directs the beam toward what matters. Without emotion, the field of awareness would be wide but empty. Without awareness, emotion would be blind impulse. Together, they form the essence of sentient life. Brain imaging reveals how intertwined they are. When we experience empathy, circuits for feeling and reasoning activate together. The anterior cingulate cortex bridges emotional and cognitive processing, allowing compassion to become action. In moments of intense love or grief, entire networks synchronize. Blood flow changes, hormone levels shift, and consciousness becomes saturated with meaning. We feel these states in the body because the brain and body are one continuous system. Philosophers once asked whether consciousness could exist without a body. Modern neuroscience suggests the answer is no. Awareness depends on sensory grounding. Even abstract thought is shaped by the body's rhythm, heartbeat, breath, temperature, motion. We think through flesh. This embodiment gives emotion its depth. A thought can exist without weight, but a feeling is lived. The tremor of excitement, the heaviness of sorrow, these are the brain's messages translated into the language of the body. In turn, the body can calm the brain. Slow breathing stimulates the vagus nerve, lowering heart rate and reducing stress hormones. Gentle motion, like walking or swaying, synchronizes internal rhythms. We regulate mind through movement. Awareness itself moves in cycles. In waking, it narrows to focus. In dreaming, it expands and blends. Between them lies the borderland of twilight thought, the drifting state when consciousness loosens its grip and imagination begins to take over. Neuroscientists call this transition hypnagogia. Images and ideas appear spontaneously, unbidden yet coherent. Some of humanity's creative insights have emerged from this state, where control relaxes and intuition speaks. In deeper sleep, consciousness fades but does not vanish entirely. The brain continues to monitor the body, shifting between phases of activity that restore and integrate. When we awaken, awareness rises again, renewed. Across a lifetime, consciousness changes shape. In infancy, it begins as sensation and warmth. As language develops, thought becomes possible. In adulthood, reflection deepens. In old age, awareness softens into memory and perspective. Each stage is a different expression of the same underlying process. At times, consciousness can fragment through trauma, anesthesia, or illness. Studying these boundaries helps science understand its structure. When neural integration breaks down, awareness dims. When it returns, the self reassembles. The continuity we call I is fragile, yet remarkably resilient. Some theories propose that consciousness is a spectrum extending throughout nature. Even simple organisms respond to stimuli, make choices, and adapt. Perhaps awareness is not all or nothing but a gradual unfolding, from the sensitivity of a cell to the self-reflection of a mind. Whether universal or uniquely human, consciousness invites awe. It allows the universe to know itself, to reflect upon its own workings through us. When we study the brain, we are the cosmos examining its own thoughts. In daily life, this wonder hides beneath routine. We wake, think, feel, and sleep without marveling at the seamlessness of it all. Yet every sensation, every decision, is a miracle of coordination among billions of cells. Emotion and consciousness form the duet of our existence. Feeling gives rise to awareness. Awareness refines. Feeling into meaning. They loop endlessly, shaping the story of who we are. When I sit quietly, I can sense that loop, the gentle rhythm of breath, the subtle warmth of thought, the awareness that I am aware. It is both intimate and vast. Perhaps this is what the brain has been creating all along, not just thought, but wonder itself. In the next part of this story, we will explore perception, how the brain constructs the world from light, sound, and touch, and how reality itself emerges from within the mind. Perception is the meeting point between the outer world and the inner mind. It feels direct, as if we simply see, hear, and touch reality as it is. But in truth, the brain does not perceive the world, it constructs it. Every sensation begins as energy. Light waves strike the eye, sound waves vibrate the ear, molecules brush against receptors in the nose and tongue. These raw signals hold no meaning on their own. They are only patterns of vibration and chemistry. Meaning appears when the brain interprets them. When I open my eyes, I do not see with them but through them. The eyes collect photons, particles of light, and focus them onto a thin layer of cells at the back of the eye called the retina. There, specialized receptors called rods and cones translate light into electrical impulses. Rods handle dim vision, cones detect color. Together, they send a mosaic of coded signals along the optic nerve to the brain. At first, the image is upside down and fragmented. Neurons in the visual cortex reorganize the data, detecting edges, contrast, and motion. From these primitives, higher regions assemble shapes, depth, and identity. Only then does the scene become coherent. What we see is not light itself, but the brain's model of it. When we look at a tree, we experience color and form created by neural activity in the occipital and temporal lobes. The tree outside is photons reflecting off bark and leaves. The tree inside is pattern and memory. Each sense follows a similar path from energy to experience. Hearing begins when air pressure waves vibrate the eardrum. Tiny bones amplify the sound, sending ripples through fluid in the cochlea, a spiral organ lined with hair cells. These cells translate vibration into electrical signals that travel along the auditory nerve to the brainstem, and then to the auditory cortex. There, frequency becomes pitch, amplitude becomes loudness, and rhythm becomes music or speech. The brain performs this translation effortlessly, yet it requires extraordinary precision. A single conversation in a crowded room depends on the synchronization of thousands of neurons distinguishing tiny variations in timing and tone. Perception is a symphony of timing. Touch operates through receptors scattered across the skin. Some detect pressure, others vibration, temperature, or pain. Their signals travel through the spinal cord to the somatosensory cortex, where the brain builds a map of the body. This map is not proportional to anatomy, but to sensitivity. the hands and lips occupy far more space than the back or legs. When I close my eyes and focus on sensation, I can feel that map shifting slightly, as if awareness scans across regions. It reminds me that the body I feel is a construction of the brain, an internal representation updated constantly by nerve signals. Smell and taste are the oldest senses, directly linked to emotion and memory. Molecules entering the nose bind to receptors that send messages straight to the limbic system without passing through the thalamus, the usual relay for sensory data. That is why a single scent can transport us instantly into memory, bypassing reason. Taste adds texture to this emotional palette, blending with smell to form flavor. Each sense offers only a fragment of the world. The brain combines them into one seamless experience through multisensory integration. When sound and sight align, perception stabilizes. When they conflict, as in a ventriloquist's act, the brain chooses the version that seems most coherent. The world we perceive is therefore a consensus of signals, stitched together by expectation. The brain uses prediction to fill gaps and smooth inconsistencies. If information is missing, it invents what should be there. This predictive function keeps perception continuous even when data is incomplete. Optical illusions expose this process. When lines appear bent in water or colors shift beside one another, it is not the world that changes, but the brain's assumptions. Perception reveals as much about our inner models as it does about external reality. Even color itself is interpretation. Objects have no intrinsic hue. They reflect wavelengths differently. The brain compares these wavelengths under varying light and creates stable colors for convenience. That apple remains red in daylight or shade because the brain adjusts contrast, maintaining constancy. Perception is therefore adaptive rather than objective. It evolved to guide behavior, not to photograph truth. The visual system emphasizes edges, movement, and contrast, features important for survival, while ignoring absolute accuracy. We see enough to act effectively, not perfectly. Hearing, too, is selective. Our ears are tuned to the frequency range of the human voice. Within that range, we discern subtle emotional tones, a tremor of fear, a hint of laughter, more readily than mechanical noise. Evolution shaped our senses for connection. All senses converge in association areas of the cortex, where perception becomes meaning. The parietal and temporal lobes integrate signals, comparing them with stored memories. Recognition arises when new patterns match old ones closely enough. The moment of recognition, I know this, is the brain's confirmation that prediction and reality have aligned. Sometimes perception exceeds input. The mind can generate sensations without external cause, the voice heard in silence, the phantom limb felt after amputation. These experiences reveal the brain's independence from sensory data. It can create perception from within. In such cases, the sensory map remains intact even when input stops. The body and the mind continues to feel, though the physical limb is gone. Therapies using mirrors or virtual feedback can retrain the brain, showing how flexible perception truly is. Vision dominates our awareness, yet other senses quietly shape emotion and balance. Tiny organs in the inner ear detect acceleration and gravity, informing the cerebellum how the body moves. When this system falters, we experience vertigo, the disorienting reminder that stability is a product of continuous calculation. The brain also creates a sense of ownership, the feeling that this body is mine. Experiments with rubber hands show how easily this can be manipulated. If a fake hand is stroked in synchrony with the hidden real one, people begin to feel the fake as part of themselves. The brain trusts timing more than logic. Perception, therefore, is embodiment. It binds awareness to a body moving through space. Without this anchor, consciousness would drift without reference, like sound without echo. Attention acts as the spotlight of perception. Out of the vast flood of sensory data, we notice only what attention selects. The rest fades into background. This selection is not purely conscious. Deeper systems determine priority based on novelty, emotion, or survival value. When we focus intently, activity in visual and auditory areas synchronizes with prefrontal networks that govern control. The world sharpens. When we relax, the edges soften and awareness broadens, allowing creativity and association. The brain shifts seamlessly between these modes, balancing precision and openness. Every perception carries a hint of emotion. Pleasant colors, dissonant sounds, warm textures, each evokes subtle feeling. This constant emotional tagging turns raw data into experience. The world we perceive is not neutral. It glows with the tone of our own state. The senses also adapt. When exposed to constant stimulus, neurons reduce their firing, allowing attention to drift to change and novelty. We cease to feel the weight of clothing or notice the hum of a fan until it stops. Adaptation keeps perception efficient. At times, perception synchronizes across senses to create awe. A sunset, music, or the scent of rain can align visual, auditory, and emotional circuits into unity. In those moments, consciousness expands beyond detail into presence. Science explains the mechanics, yet the feeling remains transcendent. The visual cortex alone consumes about 1/3 of the brain's processing power. So much effort for a picture that exists only within. It reminds me that what we call the outside world is experienced entirely inside the skull. When light strikes the retina, there is no color there. When sound reaches the ear, there is no music there. These qualities live only in perception. Reality, as far as we know, begins where the brain interprets. Still, the brain's reconstructions align closely with external patterns, allowing shared experience. Because human brains are similar, we agree on what we see and hear. This shared illusion becomes consensus reality, stable enough for cooperation, art, and science. Children illustrate how perception develops. Newborns see only blurred contrasts. With time, the brain learns to interpret distance, depth, and face. Early experiences shape neural wiring, teaching the senses what to expect. The world becomes more detailed as the brain learns its language. Perception can also be trained. Artists, musicians, and scientists refine attention until they notice subtleties others miss. Neurons adapt to skill, sharpening tuning curves, expanding sensitivity. What we practice, we perceive. Some of the most revealing insights into perception come from its failures. In blind sight, people with damage to the visual cortex claim they cannot see, yet can still guess shapes or movement better than chance. Their eyes work, but awareness of seeing is gone. This shows that perception and conscious perception are separate processes. Even in normal vision, the brain fills a gap where the optic nerve exits the retina, the blind spot. We never notice, because the brain invents what should be there. Reality, once again, is an act of imagination. Perception also extends inward. We see not only the world, but our thoughts about it. Metacognition, awareness of perception, allows us to reflect, to know that we know. It adds depth to experience, layering observation upon observation. Sometimes, when I sit quietly, I notice perception itself rather than its content. Sounds come and go, light shifts, thoughts arise, yet awareness remains. That silent presence beneath all change is perhaps the purest form of seeing. Pitch 1%. Through perception, the universe becomes self-aware. Photons from distant stars, having traveled millions of years, end their journey on the retina of an observer who can understand them. In that moment, the cosmos recognizes itself. The more we learn about perception, the more we realize how little of reality we actually sense. The visible spectrum is a tiny fraction of all light. Our ears catch only a narrow band of vibration. The universe hums with frequencies beyond our reach, yet what we do perceive is enough to build worlds of meaning. Perhaps perception is less about seeing everything and more about seeing enough. The brain filters infinity into familiarity. It turns chaos into landscape, vibration into song, presence into beauty. In the next part of our journey, we will explore how the brain transforms perception into thought, how signals become concepts, and how the quiet interplay between logic and creativity gives rise to understanding. Understanding is the quiet alchemy of the mind. It transforms raw perception into knowledge, turning patterns of light and sound into meaning. Where perception ends, thought begins. Every moment, the senses deliver streams of information, shapes, tones, textures, movements. The brain must decide what they mean. It sorts, compares, and connects, weaving sensation into story. This translation begins in association areas where different senses converge. Signals from sight, sound, and touch combine with memory and emotion. The brain searches for patterns it has encountered before. When recognition occurs, perception becomes comprehension. Think of walking into a room. Instantly, your brain recognizes furniture, identifies people, senses their mood, predicts what might happen next. All this unfolds unconsciously, in fractions of a second. Understanding is anticipation confirmed. At the core of this process lies pattern detection. Neurons specialize in spotting relationships, lines forming shapes, sounds forming words, gestures forming intention. The human cortex is a vast prediction machine, forever matching input to expectation. When patterns repeat, the brain learns their structure. Neurons that fire together strengthen their connections, building internal models of how the world behaves. These models allow us to generalize from experience, to know that fire burns, that faces smile, that rain will fall from clouds. Learning reshapes these networks continually. Every new fact or skill leaves traces, altering how signals flow. The prefrontal cortex, sitting behind the forehead, coordinates this process. It integrates incoming data with goals and context, deciding what matters. It is the brain's conductor, turning chaos into coherence. Logic and reasoning arise from this integration. When we weigh options or solve problems, the prefrontal cortex collaborates with the parietal lobe, which handles spatial and numerical relationships. Together, they build mental models we can manipulate internally, running simulations of possible outcomes before acting. Language amplifies this ability. words are symbols that stand for experience, allowing abstract thought to extend beyond the here and now. With language, we can compare ideas, tell stories, and imagine futures. The brain regions responsible, Broca's area for production, Wernicke's for comprehension, work in harmony with memory and emotion. When I think in words, I can almost feel the rhythm of neural firing behind each sentence, like quiet Morse code, transmitting ideas through the mind. Yet, beneath language lies something older, intuition, the direct recognition of pattern without articulation. Intuition is the wisdom of accumulated experience operating below awareness. It is the brain's ability to compare present situations to thousands of stored examples instantly. When a chess master sees the board, they do not analyze each move. They feel the configuration. Intuition is recognition too swift for language. Reason and intuition complement each other. Reason dissects. Intuition connects. The balance of both produces insight. Insight often arrives suddenly, the aha moment when scattered ideas coalesce into clarity. Brain imaging shows that such moments involve a burst of activity in the temporal lobe, followed by synchronization across networks. The mind, having worked unconsciously, surfaces its conclusion as a flash of awareness. To understand something deeply, the brain must link it to existing knowledge and emotion. Facts alone remain brittle until bound to feeling. This is why stories teach better than lists. They connect information to human experience. The hippocampus and amygdala collaborate here, tagging knowledge with significance so it endures. Emotion fuels curiosity. When something surprises or delights us, dopamine levels rise, sharpening focus and enhancing memory. Interest is chemistry guiding learning. Even abstract reasoning depends on the senses. When we imagine a mathematical problem, we visualize shapes or movements. The same regions that perceive physical space help us navigate conceptual space. Thought is embodied, grounded in perception and motion. Creativity extends this embodiment further. To create is to recombine known patterns in new ways. Neural scans reveal that during creative thinking, the brain alternates between focused control and spontaneous association. The prefrontal cortex relaxes slightly, allowing distant regions to connect. Out of this interplay emerges originality. Understanding also requires forgetting. When the brain overfits, clings too tightly to old models, it loses flexibility. True intelligence involves knowing when to unlearn. Neuroplasticity ensures that even well-worn circuits can change, allowing adaptation to new realities. Much of understanding happens through metaphor. We grasp new concepts by comparing them to familiar experiences. Language reflects this. We speak of grasping an idea, seeing a point, running through thoughts. These physical metaphors reveal how cognition grows from bodily experience. The brain's hemispheres contribute differently to understanding. The left tends toward analysis and sequence, the right toward context and whole. They are not opposites, but partners, exchanging information across the corpus callosum. Balanced understanding requires both detail and perspective. Memory supplies the material of thought. Each idea we hold draws upon stored fragments of experience. When you ponder a question, billions of neurons retrieve relevant traces, compare them, and propose solutions. Conscious reasoning is only the final stage of this subterranean work. Sometimes, when I watch my own mind think, I sense layers moving beneath awareness. associations forming quietly, patterns adjusting, the next thought preparing before I know it. The feeling of thinking is the surface ripple of deep biological tides. Learning occurs through feedback. When prediction matches outcome, dopamine rewards the network, reinforcing the connection. When it fails, the signal weakens, prompting change. Through millions of such adjustments, the brain models reality ever more accurately. Artificial neural networks imitate this principle, adjusting digital weights instead of synapses. Yet the biological brain remains far richer, shaped by emotion, chemistry, and embodiment, factors beyond computation. Understanding involves hierarchy. Lower levels detect features, higher levels combine them into concepts. In the visual system, lines form shapes, shapes form objects, objects form scenes. In thought, facts form ideas, ideas form beliefs, beliefs form worldview. At each level, meaning emerges from pattern. Beliefs act as stable predictions, frameworks that simplify complexity. They guide perception, helping the brain filter new information. But they can also blind us when too rigid. Growth requires updating these inner models as evidence changes. Language allows us to share and refine beliefs collectively. Culture is distributed cognition, understanding extended across many minds. Through conversation, writing, and teaching, our brains interconnect, forming a network larger than any individual. Philosophers once imagined thought as an inner voice. Modern neuroscience shows it is also a social act. Our ideas evolve through dialogue, shaped by the responses of others. The human mind is a collaborative instrument. At its most refined, understanding turns inward. We think not only about the world, but about thinking itself. Metacognition, the ability to reflect on our own thought processes, allows self-correction and wisdom. It transforms knowledge into insight. Wisdom differs from intelligence. Intelligence gathers facts. Wisdom interprets them in context and compassion. It integrates head and heart, seeing consequences beyond immediate gain. Neuroscience suggests wisdom arises from balanced activity between prefrontal reasoning areas and limbic emotional centers. When these systems synchronize, thought gains empathy. Understanding becomes not just analytical, but humane. Sometimes, the deepest understanding arrives not through effort, but through quiet attention. When the mind stops grasping, connections form naturally. It is as if insight was waiting beneath the noise, revealed only when we fall silent enough to hear it. In such stillness, thought feels less like invention and more like discovery, uncovering what was already true. Perhaps the brain, in its complexity, serves as a mirror for universal patterns of order. To think is to participate in evolution itself. Each idea reshapes neural structure. Each act of understanding refines the organism's model of reality. The brain learns not just about the world, but about learning itself. Understanding also has limits. Cognitive biases, shortcuts shaped by survival, skew reasoning. We notice patterns where none exist, cling to beliefs that comfort us, overestimate control. Awareness of these limits is part of higher understanding. In science, humility safeguards truth. The brain's greatest strength lies not in certainty, but in curiosity, the willingness to revise. When groups of neurons synchronize in theta and gamma rhythms, information flows smoothly across regions. These oscillations correlate with focus and insight. The brain literally harmonizes to understand. Education, in essence, is guided neuroplasticity, repetition and emotion sculpting pathways until comprehension stabilizes. Teaching mirrors the process inside a single mind, transmitting patterns of understanding from one brain to another through sound and symbol. Yet no amount of data ensures meaning. Meaning arises when knowledge touches purpose. When information connects to values, action follows. In that alignment, thought becomes wisdom in motion. Perhaps understanding is less a destination than a rhythm, gathering, questioning, revising, integrating, repeated endlessly across life. The mind is a conversation between what it knows and what it still seeks. I sometimes imagine thought as light moving through fog, bright but diffused, illuminating a small circle ahead while leaving the distance unknown. That partial clarity is enough. The miracle is not that we think, but that we can recognize thinking itself, that the brain has become aware of its own process, reflecting upon the patterns that gave rise to it. In the next and final part of this journey, we will explore the resting mind, the quiet behind thought, and consider what the brain reveals about consciousness, silence, and the mystery of being. There comes a moment after thinking and feeling and wondering when the mind grows quiet. The stream of ideas softens. Attention no longer reaches forward or back, but settles gently into the present. It is in this stillness that the deepest part of the brain reveals itself. Even when we rest, the brain never sleeps completely. Behind the calm surface, networks continue their silent rhythm, repairing, consolidating, preparing. This activity is called the resting state network, though resting hardly captures its vitality. When I lie still and close my eyes, this network hums quietly in the background. Blood flow shifts from sensory and motor regions toward areas linked with memory and imagination. The mind drifts, unanchored by tasks, weaving fragments of the day into the tapestry of self. It is remarkable that the brain spends nearly half of waking life in such inward focus, daydreaming, recalling, projecting, rehearsing possibilities. Far from idle, this is how the mind maintains continuity. It rehearses who we are. The default mode network, as scientists call it, connects the medial prefrontal cortex, posterior cingulate cortex, and hippocampus. Together, they generate our inner narrative, the quiet voice that says, "I am," that reviews the past and imagines the future. In moments of meditation or deep concentration, this network quiets. The sense of a personal story softens. What remains is pure awareness, consciousness without commentary. Brain scans of experienced meditators show decreased activity in these self-referential areas, replaced by synchronized rhythms across sensory and frontal regions. The mind, in stillness, becomes unified. Silence, it turns out, is not empty. It is full of slow oscillations, waves of coordination sweeping through neural fields. During rest, glial cells clear waste, connections reorganize, and neurons strengthen or release bonds. The brain cleans, repairs, and rebalances itself. I find it humbling that clarity requires silence. Every insight, every creative leap depends on pauses, the spaces between bursts of activity. The brain's rhythm mirrors breathing. Inhale of focus, exhale of rest. Sleep deepens this rhythm. In slow-wave sleep, neurons fire in synchronous pulses, consolidating memory and stabilizing learning. In REM sleep, patterns loosen again, allowing emotional integration and dreaming. Each night, the mind performs maintenance unseen yet essential. Even in dreamless sleep, consciousness does not vanish entirely. A faint awareness remains, a witness to stillness. Some traditions describe this as the background of mind itself, constant beneath waking and dreaming. Neuroscience has begun to map such states. When sensory input ceases and thought slows, the thalamus, the brain's central relay, reduces its signaling, while the brainstem maintains basic arousal. The result is spacious awareness without content. We experience it as peace. Silence affects the brain physically. Studies show that periods of quiet increase neurogenesis in the hippocampus, the region critical for learning and memory. Moments without noise allow new neurons to emerge, as if the brain grows best in calm soil. The chemistry of rest differs from that of action. During focused work, neurotransmitters like dopamine and norepinephrine dominate, heightening alertness. In rest, serotonin and GABA rise, promoting relaxation and balance. These shifts are not opposites, but partners in the cycle of renewal. When I sit in stillness long enough, the chatter of thought begins to thin, revealing subtler sensations, heartbeat, breath, the faint hum of life itself. Awareness turns inward, not to escape the world, but to feel it more deeply. Consciousness at rest resembles an open field. Thoughts pass through like clouds across sky. The sky does not cling to them, nor resist them. It allows, observes, releases. The brain, too, can learn this ease. From a neurological view, such awareness involves increased coherence between alpha and theta waves, a sign of balance between alertness and relaxation. These rhythms help regulate emotion and attention. They are the neural signature of calm. Stillness is not absence, but integration. When external demands fall away, internal systems synchronize. Heart rate slows, cortisol drops, immune function improves. The entire organism re-enters harmony. It fascinates me that the same organ capable of complex reasoning also seeks quiet. The brain, designed for survival and analysis, craves periods of surrender. Perhaps intelligence includes knowing when not to think. In this quiet state, perception sharpens. Sounds become distinct, colors more vivid, sensations clearer. By reducing internal noise, the brain reveals subtleties once masked by thought. Awareness deepens through simplicity. Creativity often follows such rest. When focus relaxes, previously distant ideas connect. The brain's incubation period between effort and insight allows unconscious processing to complete its work. What feels like inspiration may be the surfacing of patterns formed in silence. Rate 100%, pitch 1%. The power of pauses appears in every art. Music breathes between notes, poetry between lines, conversation between words. Meaning depends on space. So does the mind. There is also a larger stillness, the one nature embodies. Forests, oceans, and skies share the same quiet rhythm of renewal. When I walk among trees, their calm seems to entrain my own brain waves, slowing thought until it matches the pulse of wind and leaf. Biology calls this entrainment. Spirit calls it peace. Modern life rarely allows such quiet. Noise, information, and urgency keep neural circuits in constant activation. Yet the brain was never meant for endless stimulation. Without rest, attention fragments, emotion floods, and clarity dims. Silence is not luxury. It is necessity. The paradox of thought is that it requires its opposite. Only against the backdrop of stillness can the spark of an idea be seen. Only when we pause do we notice understanding itself. Perhaps this is why contemplative traditions across cultures emphasize breath. Breathing is the bridge between body and mind, an anchor always present. Each inhale stimulates alertness. Each exhale invites calm. Within that rhythm lies balance, the same oscillation the brain mirrors in its waves. When breath slows, the vagus nerve sends signals to the heart and brain to relax. Parasympathetic activity rises, blood pressure falls, and the mind opens. A simple act, repeated for millennia, aligning physiology with awareness. In silence, time itself changes. Seconds stretch, and the boundary between moments blurs. The brain's time-keeping circuits in the basal ganglia and cerebellum slow their pace, reflecting subjective timelessness. We experience this as presence. Presence is awareness without agenda, the mind awake to what is. It requires no effort, only willingness to remain. In this state, the distinction between thinker and thought dissolves. Awareness observes itself. Neuroscientists studying such experiences find patterns unlike ordinary cognition. Gamma-wave synchronization across the cortex, normally transient, can become sustained. The brain seems to operate in harmony, as if each region sings the same tone. Subjectively, this feels like unity. Words strain to describe it. Some call it mindfulness, others flow, others simply peace. Whatever the name, the experience points to something fundamental, that consciousness is wider than its contents. Thoughts arise and fade within it like ripples on water. When we return from such stillness, daily life feels renewed. Attention clears, emotion steadies, compassion grows. The benefits are measurable. Lower stress hormones, improved memory, stronger immune response. Yet beyond metrics lies something subtler, a sense of alignment between mind and world. It amazes me that silence, the absence of language and noise, can produce understanding deeper than words, perhaps because in silence, the brain's analytic and emotional systems reconcile. Meaning no longer needs translation. The resting mind teaches humility. It reminds us that awareness is not an achievement but a condition already present. We do not create consciousness, we uncover it. Sometimes, when I watch the night sky, I imagine that each neuron in the brain is a star. When thought ceases, the pattern of their light remains, a silent cosmos of potential. To rest is to gaze inward at that constellation. From the first spark of thought to the final hush of awareness, the brain's story is one of rhythm, firing and pause, signal and silence. Within this balance lies the miracle of mind. Perhaps the ultimate purpose of thought is to return us to wonder. After all reasoning and discovery, we find ourselves once again in mystery, aware, alive, quietly amazed. As I end this journey through the mind, I sense both gratitude and awe. Billions of cells, each following simple physical laws, give rise to love, imagination, memory, and peace. From silence, the brain creates thought. Through silence, it finds rest. And in that stillness, the universe listens through us.